Okay, let's continue, people. Last class, where did we stop? We did conductivity, then we did molar conductivity, then we did I think numericals on the same. ठीक है, आज थोड़ा सा कंटिन्यू करते हैं. The next topic that we have, people, is variation in kappa. Kappa stands for what, people? Conductivity. It can be also called as specific conductivity or specific conductance if the distance between the electrodes is 1 centimeter and the cross sectional area is 1 centimeter square. So variation in conductivity and molar conductivity with dilution. चलो, and यहाँ पे lambda m is molar conductivity और molar conductance, कुछ भी बोलो. Okay, now let's say, people, I have a beaker in which I have some volume of solution. ठीक है, and इसमें I have, let's say this is a solution of NaC. And I am giving a hypothetical value that इसमें, let's say there are 10 ions of Na plus and 10 ions of Cl minus, and this is some volume. One liter, 1 centimeter cube, कुछ भी बोलो. With me till here? Now, what I'm doing is I am increasing the volume. You can see you're increasing the volume, or I am diluting the solution. 1 liter solution में how many ions were there? And how many ions of Cl minus were there? 10. So now if I dilute, let's say from 1 liter to 2. So if I increase the amount of solvent, let's say some more ions dissociate. Let us say I get 5 more ions of Na plus and I get 5 more ions of Cl minus. Now what is the total volume? 2 liters. What is the total number of ions? 15. I have 15 ions of Na plus and I have 15 ions of Cl minus. But if I look at kappa, how do you define kappa? Conductivity को कैसे define करते? It is the conductivity of ions per unit volume. I repeat, it is the conductivity of ions per unit volume. Initially, when we started with 1 liter, how many cations were present per unit volume? How many anions were present? But when you diluted the solution, now how many cations are present per unit volume? 7.5. And how many anions are present? So if I keep on diluting the solution, what will happen to conductivity kappa? It decreases. इधर तक basics समझा? If I keep on diluting the solution, conductivity will keep on decreasing. Though the number of ions is increasing, but conductivity of ions per unit volume. समझे इधर तक? Anyone who did not get that? But what happens to molar conductivity? How do you define lambda m? It is the conductivity of 1 mole of electrolyte in V centimeter cube solution or V volume solution. Now tell me, let us assume कि वो पहला 1 लीटर में ना it was 1 mole of electrolyte. So 1 mole electrolyte जब पहले डाला हमने, it gave us 10 moles of Na plus and 10 ions Na plus, 10 ions Cl minus. Then I added 1 more liter. Some more ions are produced. Since number of ions have increased, what happens to molar conductivity? It increases. Does it matter the amount of volume present? Molar conductivity is the conductivity of 1 mole of electrolyte. ऐसा बोला है क्या? It is the molar conductivity of 1 mole of electrolyte per unit volume? No. So the moment I added more solvent, the number of ions increased. I add 1 more liter. What happens to molar conductivity? It will further increase. I keep on adding. Molar conductivity will keep on, because if I now compare it with dilution, as I keep on diluting the solution, what happens to molar conductivity? It keeps on. That is also given by, what is the expression for lambda m? Lambda m is equal to kappa by C. Yes or no? दो हमने दो फॉर्मूला लिखा है, 1000 kappa by m and kappa by 1000 m. ऐसे भी लिख सकते हैं, or I can say molar conductivity is kappa times V. Mathematically देखना है तो as V increases, what will happen to lambda m? It will increase. Or if I keep on diluting the solution, what is going to decrease? So obviously what is going to increase? Lambda m. Yes or no? I have a question. If I keep on diluting, when will I get maximum lambda m? When यहाँ पे C tends to or V tends to. Did people get that? The molar conductivity at infinite dilution or at 0 is known as lambda m naught, 0 concentration, or you can also write this as lambda m infinity. Molar conductivity at infinite dilution or molar conductivity at 0 concentration. Did you people get this? Yes or no? In short, we can say that as volume of solvent increases, as dilution increases, what happens to kappa? Conductivity kappa decreases. And what happens to molar conductivity? Lambda m increases. Did you people get that? Anyone who didn't understand this? Simple hai? Chalo. Now let us plot this. तो यहाँ पे I have molar conductivity and over here I have concentration. So this is lambda m. यहाँ पे I have square root of concentration. We're plotting it. दोनों तरफ से plot करते हैं. As dilution increases, kappa will decrease, lambda m will. उल्टा बोल दूं तो if concentration increases, kappa will increase and lambda m will decrease. Did you people get that? Yes or no? या इसको उल्टा देखो. As concentration decreases, yeah, as dilution increases, what happens to lambda m? Yes or no? And if you keep on diluting, when will we have maximum molar conductivity? At zero concentration or at infinite dilution? But can you really have infinite dilution, zero concentration? Zero concentration का मतलब क्या? Salt ही नहीं है. Excellent. इलेक्ट्रोलाइट ही नहीं डाला. Did you people get that? So यहाँ पे हम ग्राफ को पीछे क्या करेंगे? एक्सट्रापोलेट किया ग्राफ पीछे करते ना मैथ्स में. आई थिंक यू विल डू दैट. This point at zero concentration, what do you call lambda m? Lambda m naught, or it's also called as lambda m infinity. How do you define lambda m naught? Molar conductivity or molar conductance at या lambda m naught, सर lambda m infinity भी लिख सकते. That means molar conductance at infinite dilution. Any questions over there? Now this plot is for a strong electrolyte. What do you mean by strong electrolyte? Alpha almost equal to, you can consider this is for a strong electrolyte. But what if we have a weak electrolyte? I repeat, how will the plot look like if we have a weak electrolyte? क्या difference आएगा people plot में if we have a weak electrolyte? The plot will look like Did we get that? Will we ever reach zero concentration यहाँ पे? कि at infinity? This is for a weak electrolyte. What is weak electrolyte? Give me an example, people. Can I do it for CH3COH? नहीं. See, CH3C on a weak electrolyte, it's a salt of. So when you put that, it will dissociate completely. Weak electrolyte कौन है यहाँ पे? CH3COOH. समझा ये? चलो. अभी इस प्लॉट का will go उल्टा. Give me the equation for the plot. Y axis क्या है? Lambda m. X axis root c. बराबर. This equation is of the form y is equal to mx minus mx plus c. Negative slope है ना? The slope is given by A. And what is the y-intercept? Lambda m not below lambda m infinity below A की बात है. A depends on temperature. It also depends on the type of electrolyte. I repeat, A depends on, I'll give you that sub theory maybe. A depends on temperature. It also depends on the type of electrolyte. Now what does that mean? It depends on type of electrolyte. So let's say we have NaCl, MgCl2, CaCl2 कुछ ले लो, AlCl3. Type of electrolyte. So NaCl is called as a 1 electrolyte. 1 का मतलब cationic charge, ionic charge. MgCl2 is called as 2-1 type electrolyte. CaCl2 will be also called as 2-1. This will be called as 3-1. Electrolytes of the same type, A जिनका same है, they will show similar behavior. Did you people get that? इसको हम बोलते हैं type of electrolyte. चलो, quickly copy this. Variation in molar conductivity and conductivity with dilution. Okay. Now people, we have added 2 more examples here. We can add these in type of electrolyte. Lambda m naught, lambda m infinity. This is also called as, at this point, limiting molar conductivity. ये भी ऐड कर रहे हो, ठीक है? It's also called as limiting molar conductivity. Now, add a point. I'm sorry. Log. वो तो पढ़ाया नहीं था अभी तक. कोलराश लॉ इसके बाद करेंगे. Below the equation, probably the value of constant A, the value of constant A for a given solvent, the value of constant A for a given solvent, depends on temperature, and the type of electrolyte. Though we have written this, add kar do, temperature and the type of electrolyte. That is the charge produced on the cation and anion. The charge produced on the cation and anion on dissociation of the electrolyte. In the solution. Next point. All electrolytes of a particular type have the same value for A. The same value for A. Okay. Chalo. Now let's continue. The next topic that we have, people, is Kohlrausch Law of independent migration of ions. Let's first understand what the law is trying to tell us. Definition नहीं देखते पहले, let's understand the law is. Now let's say मेरे पास एक solution है. Let's say this is, people, 0.01 molar Na plus. ठीक है? And let's say the lambda m for this, I'm taking some random value. Okay, let's say this is 100 ohm inverse centimeter square mole inverse. Similarly, मेरे पास एक और solution है, but this time it is 0.01 molar Cl minus. Okay, and let's say the lambda m this time is 50. Conductivity of Na plus ions, molar conductivity of Na plus ions here is 100, and molar conductivity of Cl minus ions over here is 50. दोनों को हमने किया मिक्स. ये हमारा हो गया फाइनल सॉल्यूशन. What do you expect the molar conductivity to be? Because यहाँ पे there would be probably, let's say, x number of Na plus ions. Here will be y number of Cl minus ions. So total number of ions would be x plus y. अगर यहाँ की conductivity 100 है, the conductivity here is 50. So this should become 150. But what was observed is the molar conductivity here is less than 150. ऐसे कैसे हो रहा है? This had probably x number of ions, this had y number of ions. दोनों मिक्स करें तो इसमें कितना होना चाहिए, people? x plus y. Because there is a chance that they may go back to that crystal lattice of NaCl. Did you people get that? However, if I infinitely dilute this, let's say I have 10 raised to minus 5 Na plus. Infinitely dilute किया, molar conductivity will obviously increase. So let's say the new lambda m naught is, I'm taking some arbitrary value, 250. यहाँ पे भी हमारे पास क्या है, people? 10 raised to minus 5 Cl minus, इसको भी take some value, let's say 150. Now when you mix them, lambda m naught कितना मिला, people? 250 plus 150, 400. Ohm inverse. In short, what is Kohlrausch trying to tell us? That the limiting molar conductivity or molar conductivity at infinite dilution for any electrolyte, I repeat, the molar conductivity at infinite dilution for any electrolyte is the sum of the molar conductivity at infinite dilution of its respective cation and the molar conductivity at infinite dilution of its anion. But this is possible only at infinite dilution. You cannot apply this for lambda m. You can apply only for lambda m naught. Now let's read what the law says. The law states that at infinite dilution, molar conductance of an electrolyte can be represented. So molar conductance, let's say the electrolyte over here is NaCl. It can be represented as the sum of conductance of cation and anion, or the limiting molar conductivity lambda m naught lambda m infinity is the sum of individual contributions of cation and anion. Did you people get that? Anyone would understand this? Yes or no? Now इसका सबसे important advantage is something like this. Let's say I have the limiting molar conductivity of HCl. Let's say that is X Siemens ohm inverse centimeter square mole inverse. Then I have the limiting molar conductivity of NaCl. Let's say that is Y Siemens centimeter square mole inverse. And I have the limiting molar conductivity for acetic acid or ethanoic acid. And let's say that is Z Siemens centimeter square mole inverse. Using this data, I can find the limiting molar conductivity for sodium acetate. How can I do that? सबसे पहला lambda m naught for HCl. How can I write in terms of individual cations and anions? I can write that as lambda m naught of individual cation and lambda m naught of the anion. What about for NaCl?
सबसे पहले m naught HCl. How can I write in terms of individual cations and anions? I can write that.
Sorry about that. Lambda m naught of NaCl. How will you write that? Lambda m naught Na plus lambda m naught Cl minus. How can I write lambda m naught for ethanoic acid or acetic acid? Lambda m naught CH, sorry, वो लिख सकते हैं पहले H plus lambda m naught CH3. And what will the expression be for lambda naught CH3 CONA? Lambda m naught CH3 COONA will be lambda m naught Na plus lambda m naught CH3 COO minus. Now if I number this as, let's say, equation number 1, equation number 2, equation number 3, how will I get the main equation? Can I say the equation is, to get this equation, to get equation 4, can I say equation 4 is equation 3 plus equation number 2 minus equation number 1. And similarly, what will the value be for equation 3 का लिखा था Z plus Y Did you people get that? Yes or no? ऐसे कुछ भी हो सकता है. If I want to know, let's say, the expression for lambda m naught for, let's say, CaCl2, how will I write this? Lambda m naught Ca2 plus 2 into lambda m naught Cl minus. Did you people get that? If I want lambda EQ for this, what was the relation between equivalent conductivity and molar conductivity? We know that equivalent conductivity is molar conductivity upon n factor. CaCl2 के लिए n factor क्या होने वाला है? 2. So that will be molar conductivity upon 2. So you can also find the equivalent conductivity from here. ऐसे they can give you any expression and they can ask कि इसकी equivalent conductivity निकालो, molar conductivity निकालो, so on and so forth. Did you people get that?
What exactly is S?
Siemens. Ohm inverse is also called as Siemens. Next. What was alpha? Degree of alpha in terms of molar conductivity is given as alpha is equal to lambda m upon lambda m naught. Chalo, what was the formula for dissociation constant K? Excellent. Alpha square C upon 1 minus alpha, assuming that alpha is not very small. Substitute. So K will be lambda m upon lambda m naught the whole into upon 1 minus lambda m naught. Expression निकालो अभी. This will become lambda m square into C upon lambda m naught square over lambda m naught minus lambda m over, pardon me, ये कट हो गया, ये कट हो गया. So what is the final expression for K? Lambda m square upon C into lambda m naught bracket में this is the expression in terms of lambda m naught and degree of dissociation यहाँ पे and dissociation constant K over here. Did you get that? Yes or no? Chalo. Look at the first question. क्या बोलता है question? The conductivity of 0.001028 molar acetic acid. So the concentration कितना दिया उन्होंने people? 0.001028 molar. Conductivity is kappa. How much is kappa given?
2.95
into 10 raised to minus 5 Siemens centimeter inverse. Calculate dissociation constant. So what are they expecting us to find? K. If lambda m naught, what is lambda m naught? Limiting molar conductivity. कितना दिया limiting molar conductivity? 390.57 centimeter square mole inverse. What is the formula for K? Excellent. Alpha square C upon 1 minus. But do we have alpha? But alpha निकालने के लिए formula क्या है? Lambda m over lambda m naught. Lambda m naught तो है हमारे पास. How much is lambda m naught? 390.5. Do we have lambda m? No, we don't. But we can. What is the formula for lambda m? 1000 kappa by m kappa by c 1000. How much is kappa? 4.95 into 10 raised to minus 5 upon 0.001028. इसको सॉल्व करके क्या मिल जाएगा? लैम्डा एम. दिस लैम्डा एम कैन बी सब्स्टिट्यूटेड हियर, तो आपको मिल जाएगा अल्फा. दैट अल्फा एंड दैट सी कैन बी सब्स्टिट्यूटेड और आपको मिल जाएगा के. कैन यू पीपल सॉल्व दिस फॉर मी? ये सॉल्व करो, सॉल्व दिस एंड क्विकली गिव मी द फाइनल आंसर. चलो जल्दी जल्दी. Okay, people, compare your answers. Lambda m का वैल्यू should be 48.15. फिर lambda m से आपको अल्फा मिलना चाहिए. अल्फा should be 0.1233 and from that you should get k. K का आंसर should be 1.78 into 10 raised to minus 5. सबको आया ये? Excellent, very nice. Now then find लैम्डा एम नॉट. ठीक है, ये इसका इक्वेशन मैं लिख नहीं रहा हूँ, इक्वेशन यही है, ये मालूम है ना सबको, यही वाला इक्वेशन है वो, इसलिए मैं इक्वेशन लिख नहीं रहा हूँ. इसी में सब्स्टिट्यूट करो, वैल्यूज डालो, आपको वो मिल जाएगा. चलो एक पीवाईक्यू कर लेते हैं. क्या बोलता है पीवाईक्यू? प्लॉट 1 लैम्डा एम वर्सेस सी लैम्डा एम for aqueous solution of a monobasic acid results in a straight line with y-axis intercept of p and the slope of s. Calculate p by s. ठीक है. Ka बोला है weak monobasic acid. Equation क्या लिखते हैं people? K is equal to, we can say alpha square c upon 1 minus alpha. बरोबर. 1 minus alpha को लेफ्ट में ले लेते हैं. So K into 1 minus alpha becomes अल्फा स्क्वायर सी. अल्फा इन टर्म्स ऑफ लैम्डा क्या लिखते हैं हम? कंडक्टिविटी एंड लिमिटिंग मोलर कंडक्टिविटी. तो ये हम सब्स्टिट्यूट कर सकते हैं लैम्डा एम ओवर लैम्डा एम नॉट. यहाँ पे डाल दो तो क्या मिलेगा? के ए इंटू 1 माइनस लैम्डा एम बाय लैम्डा एम नॉट इज इक्वल टू लैम्डा एम बाय lambda m naught the whole square into c. बरोबर people? अभी k को अंदर मल्टीप्लाई करते हैं. नो, पे अटेंशन. सो ka माइनस क्या मिलेगा? ka इंटू लैम्डा m अपॉन लैम्डा m नॉट is equal to lambda m square upon lambda m naught square into c. इसको राइट में लेके चले जाते हैं. मेरे को क्या प्लॉट करना है? 1 upon lambda m. ठीक है. सो Ka is equal to Ka into lambda m upon lambda m naught plus lambda m square upon lambda m naught the whole square into c. Divide by y axis क्या चाहिए? 1 by lambda m ना. फिर डिवाइड बाय लैम्डा m तो क्या मिलेगा? k अपॉन lambda m is equal to Ka by lambda m naught plus c lambda m upon lambda m naught square. ये Ka भी नहीं चाहिए because I want to plot 1 by lambda m. So now I'll divide throughout by K, तो ये मिल जाएगा 1 अपॉन लैम्डा m इज इक्वल टू 1 अपॉन लैम्डा m नॉट प्लस C 1 अपॉन KA लैम्डा m नॉट स्क्वायर इंटू C लैम्डा m. With me till here? अब थोड़ा सा I have to just shuffle the equation. So 1 upon lambda m is equal to this part, excuse me, which is 1 upon Ka into lambda m naught square into C lambda m plus 1 by lambda m. This equation is of the form y is equal to mx plus c. बरोबर? अब क्या बोला मैंने? Y axis intercept of p. तो p का वैल्यू p is c. So p is c, which is 1 by lambda m naught, and the slope of s is m, which is 1 by Ka lambda m naught the whole square. और क्या निकालना है पीपल? p by s. इसका रेशियो निकालेंगे तो क्या मिलेगा? Ka into lambda m naught. कौन सा ऑप्शन है वो? That is the answer. Did you people understand this? ठीक है, this is a JEE Advanced PYQ. I don't remember the exact year, but I think last 2-3 साल में से कभी का तो एक का PYQ है. ठीक है, चलो copy the solution. Okay, now we will some homework questions that I want you to solve at home. ठीक है, I will see you all tomorrow. Last lecture, the last lecture we are going to do conductometric titration and we are going to do batteries, primary battery, secondary battery. I'll just give you an overview. Batteries ना ज़्यादा theoretical part है, notes में पहले दे दूँगा. It is more about थोड़ा सा memorizing reactions. And batteries के बाद एक और part होता है which is corrosion. All that एक notes में मिल जाएगा कल. So we will finish the chapter in next lecture. ठीक है? Thank you everyone. Chino?